So this video we're going to look at an introduction to R cubed, or what we call 3-space. First thing you should do is complete the handout sheet that is posted in our course VLE. So the sheet is labeled Vectors in 3-space. So complete the investigation. There are 8 questions that you're going to answer. You're going to use the following diagram shown here to help answer some of the questions. You can verify your answers using the PDF again posted in our course shell. Once you've completed this investigation and verified all your answers, then continue watching the video. Completing the investigation, you should have learned how to represent vectors in 3-space. 2 important things we're going to look at is direction and magnitude of vectors in 3-space. So from question 8 on that handout sheet or investigation, it asks you to find the magnitude of vector OP. If I take a look at vector OP here in my diagram, that's this vector right here. Using Pythagorean's theorem, I could take vector ON and NP and determine the magnitude of OP. So we have OP squared is equal to ON squared plus NP squared, the right triangle I see in my diagram. Notice that ON, the vector at the bottom, it is also part of another right triangle. It's a right triangle that goes from O to A and from A to N. So what we have is that OP squared is equal to OA squared plus AN squared, and we still have NP squared. So that's ON right there. Using equal vectors, let's keep this as OA squared. We see that AN, which is this vector here, is the same thing as O to B. So this is plus OB squared. And NP, which is this vector here, is the same thing as this vector here, O to C. So this is OC squared. And notice, if you look at those vectors, OA, OB, and OC, they just have the components x, y, and z. So therefore, we have that OP squared, or the magnitude of that vector v, so magnitude of vector v, is equal to x squared plus y squared plus z squared. So this is like a modified version of Pythagorean's theorem in 3-space. In 2-space, to find the magnitude was the square root of x squared plus y squared. In 3-space, it is just the square root of x squared plus y squared plus z squared. So given a vector v, x, y, z in 3-space, its magnitude is the square root of x squared plus y squared plus z squared. The second thing is directions of vectors in 3-space. In 2-space, we only need one direction. In 3-space, however, you need to calculate 3 different directions to identify a vector. So the 3 directions we need to use in 3-space are shown here in the diagram. We want the direction that vector v is from the x-axis, so that's this angle from here to here, it comes from the x-axis. The direction v from the y-axis, and the direction it makes from the z-axis. And we call them alpha, beta, and gamma. So here they are here. So alpha is the direction it makes with the x-axis, beta, the y, gamma with the z-axis. And to find these angles, all we need to use is our cosine ratio. So we see that the cosine of alpha is x over the magnitude of the vector. Cosine beta is y over the magnitude of the vector. And cosine gamma is z over the magnitude of the vector. So let's go through an example of how to find the direction of a vector in 3-space. So determine the direction angles for vector A given vector A is equal to -1, 2, and -3. So we start with cosine alpha, and that's equal to the x value, which is -1, over the magnitude of vector A. And if we determine the magnitude of vector A, we'll get the square root of 14. Do that here. So magnitude of vector A is equal to -1 squared plus 2 squared plus -3 squared, which equals the square root of 14. Cosine beta takes our y value, which is 2, and divide by the square root of 14. And cosine of gamma is equal to negative 3 divided by the square root of 14. Determine our angles. Say alpha is equal to the cos inverse of negative 1 over the root of 14. Beta is the cos inverse of 2 over root 14. And gamma is the cos inverse of negative 3 over root of 14. Using your calculator, you should get alpha is approximately equal to 106 degrees. Beta is approximately equal to 58 degrees. And gamma is approximately equal to 143 degrees. So notice the ratios with negative values will give you obtuse angles, and the ratio with positive values should give you acute angles. Example 2. Show that the triangle ABC with the following vertices A, 1, 2, 3, B, 1, 3, 4, and C, 0, 3, 3 represents an equilateral triangle. So to represent an equilateral triangle, we know that all three sides of the triangle must be equal. So the magnitude of AB must equal the magnitude of BC must equal the magnitude of AC. And the quickest way to find the magnitudes in 3 space is to find those 3 vectors. So let's start with AB. Remember that AB is equal to OB minus OA, the head minus the tail. So point B we know is 1, 3, and 4, or vector OB is 1, 3, and 4, minus vector OA 1, 2, 3, or the point 1, 2, 3. Subtracting, that gives us 0, 1, and 1. So there's vector AB. That's this vector right here. Next we want to find BC. That's this vector here. So vector BC again, this is OC minus OB. So we have 0, 3, and 3 minus 1, 3, and 4. And if we subtract those vectors, we end up with negative 1, 0, and negative 1. So there's vector BC. And finally our last vector A to C, which is here. So vector AC is OC minus OA. So C is 0, 3, and 3 minus vector OA, which is 1, 2, and 3. And if we subtract those, we get negative 1, 1, and 0. So there are 3 vectors. And finally, let's show that all 3 vectors are equal in magnitude. So the magnitude of vector AB is the square root of 0 squared plus 1 squared plus 1 squared, which equals the square root of 2. The magnitude of BC is equal to the square root of negative 1 squared plus 0 squared plus negative 1 squared, which is equal to the square root of 2. And finally, vector AC's magnitude is the square root of negative 1 squared plus 1 squared plus 0 squared, which is equal to the square root of 2. And now we've shown that ABC is an equilateral triangle. Try the following questions and let me know how it goes.